1. The raw supply pump transfers milk from the raw silo tanks through the balance tank inlet throttling valve and into the balance tank. 2. The balance tank inlet throttling valve feeds the balance tank. 3. The balance tank serves several purposes. It maintains a constant supply of milk at a stable level to feed the stuffing pump in diverted flow and the booster pump in forward flow. And when in diverted flow, it provides storage capacity for non-pasteurized milk returning from the flow divert valve to the balance tank. 5. The raw regenerator bypass valve is a crossbody valve that, when in diverted flow, is de-energized, allowing the flow from the balance tank to feed directly into the inlet of the stuffing pump. At this time, the booster pump is not running. 11. The stuffing pump in diverted flow supplies the flow to the clarifying separator discharge/bypass valve. 12. The clarifying separator feed/bypass valve is de-energized when the HTST is in diverted flow. 35. The homogenizer/timing pump is a positive displacement pump which maintains a constant legal raw milk flow through the holding tube in both diverted and forward flow. The homogenizer/timing pump is also responsible for supplying the pressure to move the milk through the rest of the HTST. 39. The heater section uses hot water to heat the 40-degree raw milk by a maximum of 25 degrees per pass when in diverted flow. Once in forward flow, the raw milk will be preheated in the raw regenerator section from 40 degrees to 163 degrees. This allows the heater section to add the remaining 12 degrees of temperature needed to bring the raw milk to 175 degrees as it goes into the holding tube. 44. The holding tube is where pasteurization actually occurs. The raw milk is held at or above the legal pasteurization cut-in temperature of 161 degrees for the legal minimum holding time of 15 seconds in the holding tube. Pasteurization temperature is set at 175 degrees on this HTST. 46. The digital reference thermometer displays the legal and official temperature of the raw milk leaving the holding tube. 48. The safety thermal limit recorder generates a legal record of all HTST operations. This is where the set point for the cut-in temperature of 174.5 degrees and the cut-out temperature of 173 degrees are located. The cut-in and cut-out set points control the position of the flow divert valve and the leak detect valve. When the cut-in temperature is reached, the flow divert valve will be energized, shifting into forward flow. If the temperature drops below the cut-out temperature set point, the flow divert valve and the leak detect valve will shift back into diverted flow immediately. The booster pump can only run when the flow divert valve is in forward flow, so it will shut down if the flow divert valve shifts back into diverted flow. 49. The flow divert valve separates the raw milk from the pasteurized milk. In diverted flow, it is de-energized, and the flow goes from the discharge end of the holding tube into the center port of the flow divert valve and out the bottom port as it returns back to the balance tank through the diverted flow line. 49. When the flow divert valve is energized, the HTST is in forward flow. The milk is legally pasteurized when it leaves the flow divert valve out the top port. 50. The leak detect valve has a delay of between 1 and 5 seconds after the flow divert valve is energized before it will be energized. This is to allow the area between the flow divert valve and the leak detect valve to be flushed of any raw milk that might have leaked into this area with the pasteurized milk. After the area between the flow divert valve and the leak detect valve has been completely flushed, the leak detect valve will be energized and shift into forward flow. The flow will then leave the top port of the leak detect valve and go into the pasteurized regenerator section. 52. The pasteurized regenerator section will become pressurized as the pasteurized flow goes through the pasteurized regenerator section. As the flow leaves the pasteurized regenerator section and feeds into the glycol cooler section, it will pass under the pasteurized differential pressure sensor. 53. The pasteurized differential pressure sensor sends the lowest pressure in the pasteurized regenerator section to the differential pressure controller. 54. The glycol cooler section, when in forward flow, uses 130 gallons per minute of 28-degree glycol to cool the 100 gallons per minute of pasteurized milk from 49 degrees to 34 degrees. 58. The vacuum breaker is installed in the discharge line, leaving the plate heat exchanger. It must be located at least 12 inches higher than any raw milk line in the system, so that if the HTST shuts down while in forward flow, there will be at least 12 inches more pressure on the pasteurized regenerator section than in the raw regenerator section. Number 60. The pasteurized holdback valve is energized when the HTST is in forward flow. This holdback pressure is used to maintain a higher pressure on the pasteurized regenerator section than on the raw regenerator section. 61. The discharge/recycle divert valve will be de-energized and the flow will go out the bottom port and back to the balance tank. The HTST will recirculate flow back to the balance tank as the booster pump is energized. 6. The energized booster pump will push the raw milk through the raw regenerator section. Anytime the booster pump is de-energized, the raw regenerator bypass valve will be de-energized. This allows all the raw milk in the raw regenerator section to drain back into the balance tank. 5. The raw regenerator bypass valve will be energized 10 seconds after the booster pump is energized. The flow will now go across the top of the raw regenerator bypass valve into the inlet of the booster pump. The booster pump will feed the raw milk through the raw regenerator section and then into the T in the line between the raw regenerator bypass valve and the inlet of the stuffing pump. 7. The raw differential pressure sensor is located in line between the booster pump and the inlet of the raw regenerator section. It monitors the highest pressure in the raw regenerator section and sends this pressure to the differential pressure controller. 8. The differential pressure controller monitors and compares the highest pressure in the raw regenerator section with the lowest pressure in the pasteurized regenerator section. The pressure in the pasteurized regenerator section must always be at least 1 psi higher than the pressure in the raw regenerator section. This is to satisfy the differential pressure controller and allow the booster pump to run if all other requirements are met. 10. The raw regenerator section preheats the raw milk coming from the balance tank from 38 degrees to 163 degrees, using the pasteurized milk flowing in the opposite direction in the pasteurized regenerator section as it feeds the stuffing pump. 11. The stuffing pump feeds the clarifying separator feed/bypass valve in order to supply the homogenizer/timing pump with the required 40 psi of inlet pressure.